Thank you. Right, so this is a talk about effectively working with partners on understanding the impacts of heat wave using amalgamating data. And and the cross-agency collaboration lessons that we had out of it. Public health conference very recently. So no less important to tell the meteorological community as well as the health community about how we did the work. So quick acknowledgements. It was a big team of people that we were working with. The Bureau of Meteorology led the project. I directed it from the heatwave expertise point of view, but we had the University of Adelaide involved, Department of Health, Australian Bureau of Statistics, Geoscience Australia, and the Australian Institute of Health and Welfare. And it was really an exercise in how do we leverage big data sets held by each of those agencies to learn about where people are impacted by heat wave and understand that as a vulnerability which we can use when we're trying to forecast impact. So this was funded by federal government out of a project called Funding an Environment called DIPA. And I would mention also that I'm still doing a PhD, very nearly finished, and a lot of the work that I've developed here has benefited from a Churchill Fellowship on heat waves that I did in 2000, funded in 2012, conducted in 2013. I won't have time to talk about Australia's heatwave climate or trend, nor the heatwave measurement algorithm and moments, the intensity and severity. But there have been a lot of impact studies with epidemiological partners where we've demonstrated that the severity component of heatwave correlates well to impact on health areas. And I've got a listing there for the article that describes the technique for getting out the excess heat factor. I just mentioned the key learnings we had from doing this work. The first learning was linking data is not hard, but you need good governance. It builds desire with partners to collaborate, and it ensures that you actually have strong integrity of the process. And so therefore you understand each other really well. All data set sources, meteorological, health, spatial data sets, they all have ethical issues that must be addressed. Every data custodian is worried about how the other party is going to use their data. So continual engagement with the outcome, the customer experience that you want to generate is important. And it's really important to get down to suitable temporal and spatial resolutions, because that drives the scale, the significance of what you can actually get out. And that means you go back again and talk to your partners about how you're doing the work. It's really important with health custodians to get safe and secure analyses, because otherwise they won't release the data. And also, obviously, that the hazard or environmental representation is sensitive to the impact. And that was something coming from the geophysical side from both the Bureau and Geoscience Australia, our geographical agency, that we were driving. The third lesson, that each agency has preconceptions about the data integrity and how the data will be used. So again, that customer experience, you have to get an agreement on what that customer experience is so that can drive the outcomes you're looking for. Ethics and custodian issues, you've got to make sure that it's a good fit for the queries that you're raising, so everyone has to agree on what you're doing there. Safe statistical queries are really important, and that, particularly for health, risk ratios ended up being a very safe way of generating data that satisfied everyone's needs, because that particular result cannot be paired up with other data sets to reveal identities, which is quite possible when you play with other forms of statistical results. And then you look for a safe release of the results, and you have to have strong agreement amongst the partners about how that's done. Right, and so governance, we conquered that by running a steering group. So Australian Bureau of Statistics, Department of Health, Geoscience Australia and the Bureau of Met had senior stakeholders there who were able to address the issues that were raised by various people. Either the people working with the data would raise issues and it could go back to the steering group and be resolved there. The working group was another level that we had, and here we did the real analysis. So in the Bureau, we recruited an APR intern, actually a PhD candidate who suspends their candidature to work with us. So we gained an epidemiologist, one that I had worked with, who was working on heatwave, and they ran analyses on the Bureau of Statistics data lab, and we also had project managers. Department of Health supported us with a spatial analyst, and he ran analyses on the both data lab and on the Department of Health secure servers. And there was a wonderful partnership that was struck up between our epidemiologist and that spatial analyst, and it drove, they were the engine room for the queries that we presented to Australian Bureau of Statistics and the other partners. And then the ABS, who were responsible for data stewardship for all of the custodians that they had collected data from. They always ran queries back to those custodians. They would check our statistical queries. They would create the linked data sets. So they hold many data sets that are held in separate repositories. And in order for us to run the queries, they would create a spline of data with all the records hanging off them. And very, very strong work that they did for us there. An example of some of the negotiations we did with them. Ordinarily, the Australian Bureau of Statistics, and they offered it to us day one, present us with monthly data sets and getting ready to walk away and say, off you go. We had to disillusion them and say, I'm sorry, we work with daily data. We'll need daily data sets. And took a little while for them to come on board, but in the end, they generated it. So across the entire Australian population, data sets over 10 years, that's a big data set, but they did it. And they linked up data sets such as health, medical benefits, pharmaceutical benefits, taxation, extraordinarily powerful data sets when you think about privacy issues, but they were de-identified data sets, and we had to do courses on how to be safe analysts in their environment in order to preserve their requirements for confidentiality and safety of the records. And Geoscience Australia that supplied us with Nexus and Digital Earth data sets. And Nexus is actually a national repository for building and infrastructure across the nation. The third part of governance was our stakeholder reference group. So we used these people as candidates who would use the project results, and we were able to test ideas with them and also do case studies, so that in those instances, we had the Red Cross and Queensland Health, who were also doing heat health impact mitigation projects. We were able to pair up our work. A busy diagram here, but if I spend a minute on it, it's worth looking at because the left-hand wheel should be relatively familiar for those who work in meteorological agencies. From one in the wheel there, the hazard, we data assimilate and we look at predictive models. And from those, forecasters will generate the forecast warnings. And then we get warning updates with emergency management and media inquiries that are generated. We go back into the observed hazards, we verify forecasts and warning skills, get some lesson learned, apply those back into training, and then we hold climatological data. And that, if you like, is one process. In the middle there, we've got the hazards that are possible to work through with health: heat, smoke, pollen, dust, fire, and flood. And if I look on the health side, it's similar wheel. But it's from the interest that we hold is the impact data that they hold and how they're using it in order to generate their business model for how they want to react. Either they're getting their assets in place in an appropriate level, ready for an impost, or they're putting out community messages, or they're organising their resources, such as ambulance, emergency departments, hospital admissions, general practitioners of medicine, or pharmacies, so that they can function well. They'll collect data and lessons learned, and then they'll hold impact data and they'll look after that. So the mitigation that we have for those events, on both cases, those red arrows, where we try to make sure that our warnings are in place, or on the health side, they're trying to make sure that their assets are in the right place at the right time. So if we look at that as in a combined state, we might reorder that slightly. The wheel starts at 1, where we look at health and climate epidemiological data together, and then we build joint hazard impact predictive models and move on to either separate or joined together public health messages and forecast warnings. And again, we're both in that domain where we're providing information to emergency management, media inquiries, getting our assets in the right place. And then we come back into the surveillance of the event, lessons learned, and holding the data. So our data sets for the study were mortality over a 10-year period, 2007-17, the morbidity data, where we could look at people's health impacts rather than death, and through GP visits, exposure using the excess heat factor, the Bureau of Meteorology's way in which we identify heat waves, and then look at vulnerability, such as socio-demographic, health status, risk factors, natural and built environment. And then when we look at that, we build up the data use. We had both individual and neighbourhood epidemiological work. So the study design modelled a time-stratified case crossover using conditional logistic regression model. And what that does really is it looks at the individual during a heat wave as a control. And when they move into a heat wave, if they're impacted, that's the way in which you're actually doing the case crossover. In the neighbourhood level, thank you, we're looking at 4 stages there, where we're looking at spatial scales of city, statistical area level 2s, and individual modifiers. And what was nice about doing it those 2 ways is we found that they both backed each other up in terms of how people were impacted. So we're now in a position where we can see if we can model how to forecast heatwave severity and human impact by having that vulnerability indice data set. And we can look at how we can advise the community or sectors within health how they can improve their mitigation response. So the conclusions, we've got that vulnerability risk ratios now and other profiles that are useful for both, if you like, mitigation, but also for forecasting. What might we want to do, what future collaborations are ahead of us where we can use human health impact forecasts, and the opportunity where maybe it's possible where we could look at how we team up with health and look at how we can reach different sectors and possibly conduct this type of work for asthma, bushfire smoke, dust storms, floods, and more. And so the key learnings were good governance, consider all data sources to be ethical issues, and manage preconceptions of data integrity and data use. And this is an example of what we've generated, vulnerability there with those other equations that go into vulnerability of exposure, sensitivity, and adaptive capacity across the city of Melbourne. So you can see how that varies, and even when you see how neighbouring areas vary, it's quite instructive to begin to think how people might, well, it challenges us to think about how we might want to use this. Thank you.
Thank you, John. That was really interesting. Have we got any questions from the audience? You can put up your hand. So I have a question for you, and that's about the actual production of the service and how the data actually get. Is this all done in the cloud so that I mean, who's going to maintain all this? If we do, which is what we all hope for a service. How does this get that continued support, and who, how does that all happen? Do you have an idea about that?
Well, yeah, look, there's a number of ideas that run through my head about how this data can be used. It's extraordinarily valuable across the PPRR spectrum. It's the planning, preparation, response, and recovery. When you think about how data at the suburb level, as we've revealed it there, it shows people who want to work with their community how they're exposed, how vulnerable they are. So if you like, at the local government level, there is the opportunity for people to use this data and go out to their communities and ask questions with them, work with them to learn how to do additional work. As a meteorological agency, we combine the hazard with the vulnerability, and we get the risk, the ratio of risk, the increased amount of impact we might expect to see both at mortality but also morbidity level by suburb. Is that meaningful in our forecasts? Possibly not. Possibly more across a region like a whole city or bigger regions of the country, and we have to look at how we can do that. And so I think we're only at the beginning of understanding how we could do it, because it was a big job. It took a year for us to come together and sort out the knitting so that we could actually do the work and generate these results. And now I think we need to sit down. And what I'd like to think is that there's a job there to take data like this out to communities, and they can tell us what sort of messages they would like to see when we forecast heat waves.
So we've got a couple of questions in the chat. We'll start with Rob Hunched. Would you like to unmute and ask your question?
Yeah, hello. Very, very interesting presentation. I was just wondering, the last slide, you indicated something called adaptive capacity. How is that determined or calculated?
Yeah, so I think what they've done here, and I'm not the person who's generated the data, I've been in conversation with the epidemiologist and spatial analyst, but what they've done is they have followed some of the techniques generated by the Centers for Disease Control and Prevention in America. So they've got a technique for doing it. But adaptive capacity can be seen to be available resources, proximity to health centres, your proximity to support to actually help you. So I don't have the ingredients that they used, but effectively that's where adaptive capacity is seen to be important. And what happened here was that they did this work, they cut this work, the results more than one way. One of the very interesting sets of results was to look at, by locality, the elements that came through for vulnerability, for sensitivity. And that's a possibly easier question to answer, such as high-rise buildings, or people renting, or people who didn't have cars, or people's whose socio-economic score was lower. So you had it varying across the landscape. When you look at sensitivity, you could see it varied a fair bit, and that tended to focus on those sorts of issues.
Thanks, John. We've